In this video, we're going to work through the problems that deal with direct, inverse, and joint variation. When we start reading this problem, we're told that h varies directly with the cube of m. I'm going to go ahead and just write that part down. H varies directly. I always need k, that's called the constant of proportionality. So constant of proportionality, I'm going to have that in all of these problems. There we go. So it varies directly with the cube of m, there's the cube of m, and inversely with t. Anything inverse goes in the denominator. Now the first set of information I'm given right over here is all to find k. So we're going to plug all those numbers in and we'll be able to find k. So h is 9, m is 2, and t is 6. So I'll just solve for k now. I'm going to multiply by 6, so 54. I'll cube that 2, 8k, and we'll pull up the calculator to get this number. So 54 divided by 8, and that gives me 6.75. So now I'm ready to hit with the second piece of information, which is this part. What does h equal when m equals 4 and t equals 2? So we go back in here. H equals, k is a constant, so it's going to remain the same, 6.75. M is 4, that's cubed, all over 2. And now we can just pull up our calculator to get that answer. So 6.75 times, let's see, I know 4 cubed is 64, and we're going to divide it by 2. And there we go, 216 is our answer. All right, let's go to the next problem, which is set in a situation, but the same process. The strength S, and let's just highlight this as we go along, the strength S varies inversely with the length L. So that's going to lead us to the equation that says S equals K, there's my constant again, and it's inversely with L, so L goes in the denominator. So if a beam has a length of 96, that goes in the bottom where length is, it can hold 375 pounds. So now I can just find K. So I need a calculator to help me out with that. So I've got 96 times 375. There we go, 36,000. So K equals 36,000. And so now I can answer the other question, how much can a similar beam of 128 inches hold? All right, so strength equals, my K is 36,000, and my length is 128. And I'll throw that in the calculator. Let's see, there's the 36,000 already, so divide it by 128. And there it is, 281.25. And let's get correct units on that. That's going to be pounds. All right, now in this next one, we're taking a similar problem, but having a lot more variables. So this time the strength S, write down S, varies jointly. Now jointly means you're directly with one or more things. So I'm going to have K, and what are those things? The width W, don't forget this word, and the square of its thickness T. So width and the square of the thickness, and inversely with length. So we get this more complex formula. Now we're going to take that first set of information and to figure out K. So it's all of this part. All right, so let's go ahead and get that in the formula. So let's see, we're 2 inches wide, we're 6 inches thick, we're 96 inches long, and we can hold 375 pounds. Let's see, I'm going to be taking 96 times 375, which I did up here, so I know that's already 36,000. Equals, let's see, 6 squared is 36 times 2 is going to be 72K. I think I'll pull up the calculator for the last bit. So 36,000 divided by 72, and my K equals 500. All right, so now I'm ready to take that last bit of information, which is all the stuff down here. How much can a beam hold that is 3.5 inches wide, 8 inches thick, 128 long? So here we go. S equals, our K is 500, we just found that. 3.5 is our width. 8 is our thickness, and 128 is our length. And now it's just a matter of putting it all in our calculator. We'll bring this over here. So I've got 500 times 3.5 times, let's see, 8 squared is 64, and then divide it by 128, and we get our answer of 875 pounds.